Well, this is called Pretty Nagios Chart. It doesn't say that on my sheet.
Yeah, I know.
Pretty Nagios Charts. Please put your hands together for Alexis Le-Quoc.
Thank you. Sorry, I had a little late night flash of inspiration and figured maybe that's a better title. So, but what I want to talk to you about is really a continuation of it's the same vein of the talk I gave yesterday, which is really about what you can do with your Nagios data. So data that you already have, data that you already collect, data you might not be using, you might or might not be using. So in this presentation, I basically walk through, in relatively practical terms, how to extract the data and what to do with it. I won't go into too much detail, so in terms of explaining code and stuff like that. So if you want, just hit me afterwards. This is my Twitter account, so just connect and let me know. Okay, so that's me. Again, so that hasn't changed since yesterday, but developer and operations background, been a Nagios user since 2008. A co-founder of a company called Datadog, hence the little dog. And we do basically real-time analytics. So let me start with a little survey. I would like to know, and this is not for me to gather results, but really to start the dialogue is, compared to last year, if I were to ask you in general how you feel your Nagios practice is doing, would you say it's better, it's about the same, or it's worse? Better? Okay, so for me it's maybe worse, but I think there's a distribution of answers there. The reason why I'm asking this question is, so why does it matter? If we're getting better year after year, or worse, or of course there's an element of pride. I'm doing a good job. It's better. But I think more importantly, if you're doing worse, then you don't get to sleep that much because you get waking up at night. And this is really, I think, the picture of happiness that I want to get to. And the idea is that in my Nagios data, in my stream, in my log, there are pointers that can help me answer the question, yes, I'm doing better, or no, I'm doing worse. This is by what margin and why. So I can be one of these guys. So the question is obviously, how do you find out? So yesterday I had a little, a few slides about why you can't use your memory to find out. Because if I ask you, and we had this little exercise, if I ask you what are the top 3 Nagios checks, you're going to answer, basically you're going out of all the Nagios, the service alerts, if you will, that you encountered, you're going to select, your memory is going to selectively filter to what's recent, and then second, what happened kind of out of the working hours. So something that wakes you up at night, you'll remember for a long time. Something that happens every single day or every single week on Monday at 11 a.m. where you're already in the office. This is not going to register as something that's important. Whereas if you look at maybe the impact, it might be really important for you to fix to address this service alert. So if you eliminate memory from as a tool to get to the answer, am I doing worse, better, or is it the same? Then what you have left is analytics, and this is really the topic of this little discussion. So analytics is great. Yesterday, kind of went through, diving through some data set and try to extract trends and so on. One key thing that often gets forgotten or doesn't receive as much attention as really it deserves is the importance of display and presentation. And so that's why this presentation, originally I think called JavaScript Meets Nagios, is called now Pre-Nagios Charts because I use more than JavaScript for that. But this, in case you're curious, this is a great book on how to represent quantitative information by Tufte. And so there's a huge following about this guy. You don't have necessarily to agree with everything that he says, but he has spent a number of years trying to see what charts, what representations make sense. All right, so first I want to talk about the pipeline. So the pipeline really means how do you get the data out of Nagios into something that you can print on a sheet, or look at a screen and say, yes, I can see trends, I can extract action out of that. The first thing I wanted to sort of re-emphasize is that your Nagios logs are a treasure. There's a few reasons for that. If you go back to what a log is, really, this is for many, many years, this is what a log really is. Somebody every day opens a notebook and writes down what happened, the important things that happened throughout the day. So this is from 1943, a ship's log. That's what we mostly have. Now, if you compare, what we call in the industry a log, it's something that's totally different. And unlike a ship's log, it's something that's usually very comprehensive. That's accurate, so there's no trying to remember what happened today, around what time we had an alert. The machine will write that down for you. And it's written for you, so you don't have to go through exercise of trying to synthesize what happened and then writing it down for posterity or later analysis. The problem, of course, is that what we trade in being comprehensive, accurate, and sort of easy to write is that they're hard to comprehend. I mean, this is an extract from one of the logs. Per se, each individual line is not particularly hard to comprehend. The problem is, if you just look at pages and pages of that, you're like, okay, well, it's not very actionable. Oh, and if you have any questions, comments, reactions, interrupt me. I don't really want to do like necessarily only have questions at the end. This is meant to be really as interactive a discussion as possible. So here's the recipe that I put together to extract some actionable information from Nagios data. So you have your raw logs. Everybody has that. Write a simple Python parser that extracts logs. Put these logs in the database. Apply some statistical analysis on them. So this is R, and then represent them. So then there are for representation, there are basically two avenues that I looked at and that I think are really easy to use and elegant. One is called ggplot2, which is an R package, and the other one is D3, which is a JavaScript library to represent in a very interactive way numerical data. For people who don't know what R is, it's a statistical package, the open source statistical package that's used by a lot of people, a lot of data scientists. It's open source, it's well documented, has a huge community, so it's a great package to perform statistical analysis. I'll say a few things about scale later on, but this is what I started. The data that I'm going to present you with, it went through that pipeline. So the parser extracts data from the logs. SQL database lets you query the data and kind of ask questions of the data. R lets you analyze the results and extract statistical properties of the results. And these two guys, just ggplot2 and d3.js, are just purely there for presentation. So this is the ingredients of the recipe, and they let you start from the raw logs and get you to nice graphs. So you run your log parser, insert data into Postgres, then connect R to Postgres, and so R can basically pull data from the database, and then you present it, and then you get your graphs. So in slightly more detail, if you want to do it yourself at home, and it's not dangerous, so you should, you can use, so Nagios log is there, you can, and I can share at some point if you're interested, some code to do that, to extract. It's relatively easy. Extract that into a CSV, use a Postgres utility to create a table out of CSV. It's super simple. Use a module so that R, the statistical package, can connect to the database, called R PostgreSQL. R data frame is the representation of a SQL table, if you will, in R with few caveats. And then to get to a PDF or PNG or whatever, you use ggplot2, and we'll see what it looks like.
Does R support other databases?
Yeah. So it supports, I believe, Oracle, MySQL, probably SQL Server, like most of the databases. There's a generic database interface to R called DBI, maybe something like that. And basically, you pick your database, you load the module, and R expects the database to behave in a very standard way. So there's one limitation with that, and so which in our example won't matter that much if you load a huge database, and by huge, if you have gigs and gigs and gigs and gigs of logs that turn into a table. This, you can't just pull all the data into R and do the analysis. You'll have to segment to create views of the data and then to perform the analysis on it. There's other ways to do it on the entire data set, but it doesn't quite use this pipeline. And I'll talk about that a little bit later if you're interested. But for I don't know, if you have probably, I wouldn't load into this scheme 10 years of Nagios data for 100,000 machines, but I don't know, if you have a couple of hundred machines and you want to load a couple of months, it should work fine without any issues. All right, so now let's play a little bit. So this is the environment. I'm going to show you the data for the environment for this environment. The only interesting things is just number of machines and a number of checks. So 25 machines, 400 checks. Small, but not so not huge. Relatively small. So the underlying data is using Nagios Core. So the first thing I wanted to see is the general trend. So this is the number of service alerts per day. This is day of year, so start 0 being January 1st, and then now is here. So service alerts per day, and then the two colors, which are factors, basically, is this alert notifying or is this not notifying? So you can see, luckily, there's a great, we're not getting notified 1,000 times a day, which is great. Rather, it's down there, and I'll zoom in into that one. But you see, there's it's kind of all over the place. So to get that, once you have data in R, it's 5 lines. You basically say, so this is my data. So this is my data. This is how you say it. I want to represent them as line, and this is just basically Chrome. So the data, which you say, basically this is the table I want to look, and these are the X and Y axes I'm interested in. This is geometry, so I want to draw the result as lines. And then the Chrome is just, this has changed the default label to something that's a little bit more palatable. But really, it's literally 5 lines. I mean, I've broken the first one in 3, but and I think that's the beauty of it. So you really separate the parsing and ingestion phases, which are really relatively heavy duty. Put that in a database, and then when you're done, your data is in R, and this is ggplot2. Lets you really relatively quickly kind of experiment, ask questions, and see results visually. Because if you just load data in a SQL database, I mean, even if you're very proficient at SQL, it's going to be tough to see trends and patterns because you basically get tabular data back. Even if it's 5, 10 numbers, it still doesn't. It's not as I think doesn't have as strong an impact as a graph. So the next thing I wanted to know, of course, is how am I doing? And this is really you can see the trends. So in terms of non-notifying, that does a linear regression and then displays the some confidence interval around it. So you can see that this is the non-notifying alerts, but service alerts nonetheless. There's a kind of worrisome trend in this case, which the big variations, the jitter around it is kind of hide a little bit. So when you do that, you can clearly see where you're going. So really, what you could do is you can eliminate for pure representation. We could eliminate the raw data and just keep the regressed lines. And so what that means is that 100 days, about 3 months in the year, so around March, we've been on an ascending trend in terms of service alerts, which doesn't sound too good. So there could be any reasons for that. Some checks are broken, and then they're broken. They stay broken, and we don't fix them because they're not notifying, so they kind of don't even register on the radar. Another thing is we have more problems, but somehow these problems don't affect, or they don't affect us to the point that they get notified, we turn them into notifications, or our notification criteria are just too strict, and we're ignoring a number of silent problems. So there could be any number of explanations behind it, but at least we know that a year from now, I can draw the entire 2 years and see, all right, did we keep going on an ascending trend, or did we plateau, or even better, did the number of alerts drop down? Now, beyond, I think, the specifics of this particular case, the interesting thing is that really the only difference from before is adding this, in that representation language, just adding one line that says, give me the linear regression. And so I think the beauty of this is to be able to really get visual results in a few lines of code. It takes maybe a day to kind of learn, walk through the pace of learning ggplot. There's a couple of books about that, a couple of websites. But it's really pleasing. You can generate that, and then you can generate the results in 5 minutes. Like you load the database, you load the table from your database in R, and then you start running a few commands, and boom, it's there. I'll show you, I guess, I can show you the tool that I'm using for that, the kind of the IDE for that. So then I've isolated the notifying alerts per day. Again, same deal. Now we're on what actually gets people pager or phone ringing, and the regression is okay. And obviously you can see there's a number of peaks here and there, and we could look back for this particular account and try to understand, well, what happened this day. There's probably a relatively serious problem that basically things broke loose and the pager couldn't stop ringing. So that's, yes, it's in code. So that was the first question, is kind of see how it changes year after year, not year after year, day after day during a year. Second question with the same tools, and it's just very slightly different code, and I'll show that, is tell me per day of the week what the pattern is. So yesterday I did that for a lot of different across a lot of data from a lot of different companies, a lot of different Nagios installations. In this case, it's for one particular account, so it's I think it's a little bit more, a little bit less uniform. So this is a box plot, so from Sunday to Saturday, number of notifying alerts, so times the phone rings, the phones ring, and a box plot. Basically, the line here is, I believe, the mean. This is the minimum, the maximum, the 75th percentile, 25th percentile. So basically, it lets you represent distributions in quasi 1D. I mean, in 2D, but as almost lines. So, and that's across the entire year. So, trying to see, well, is there something that's very cyclical in our activity that causes this to happen? So, in this case, not really, except, so weekends are quiet, which is, intuitively not very obvious if you know the background of this, but it's kind of interesting to see not much happening on weekend. Tuesdays see a lot of variations. And in terms of the mean, it's kind of the same. I mean, I guess it remains roughly the same, but we could get back to data and ask the questions, well, what's happening on Tuesday? And get more granular questions about which are the checks that alert on Tuesdays, which are the hosts that alert on Tuesdays. Give me this by month, and is there anything that happens month after month? So we could do that now. I think again, I don't know if this is, so you'll notice without even reading everything that this is always kind of so 1, 2, 3, 4, 5, 6, 7 lines. There's always this pattern, or you define your data, and there's very little difference here. Here you say what geometry you want, so you say I want a box plot, and then boom, you got a box plot. And this is Chrome again, is like to turn day 0 into Sunday, this kind of stuff, and change the labels. But So really, if you don't care about the Chrome, is in 2 lines, you get your representation. If you change that into something else in line, then you'll get lines. If you want areas, stack bars and so on, you can change it. So it's really a super powerful tool to look at your data, and it's a lot more. It's not quite actionable at this stage because you don't, I show you that. Even if you know the environment, you'll be like, okay, well, now what do we do? But at least it gives you pointers. It gives you direction to look into, well, let's see Tuesdays, and then we'll recompute the data or we'll rerun this graph a week from now, and let's see how Tuesdays evolve. Do we film after we do some action? So the general pattern would be, as we have fun with Nagios stats, so you get the data in your database, you run your analysis, you do stuff, you run your analysis, you do stuff, you run your analysis, and so on, till the point where you're into a zone where, okay, fine, we know that what we've done has been effective because the data is there to prove it. I mean, this is kind of the standard, pitch behind data-driven stuff. Any questions so far? Is this interesting? Makes sense? Okay. Well, all right. So I have a lot of fun doing this kind of stuff, and maybe it's just me. I don't know. Anyway, I have so much fun doing this stuff that basically we built it as a service. So and let me see what's. So that's the service is called Datadog. But anyway, so what it does is it runs in the cloud and it pulls a lot of data and then produces this kind of analytics in the end. There's a slight difference in what I talked about in what I call the play stack, where you can have fun and you can ask a lot of different questions, and the service stack, which is what we run as a company for our customers. So the main issue, the main difference really is one of scale. That's really what it boils down to. I think I like the play stack because it's super flexible. So the service stack, on the other hand, of course, is there to answer different constraints. That is to say, not be as flexible, but crunch a lot more data and then do that without manual intervention. But anyway, even what I presented earlier, which is this stack, so parser remains the same. Postgres pretty much remains the same. The only real difference is that R typically won't work at this scale. So that was your question. And then what we ended up doing is using Hadoop or using Pig, which is a dialect of Hadoop. So applying MapReduce on the data set. Because here we have, I believe, I think the data I had was like a couple of megs or 50 megs. Maybe 100 megs of data, something like that. So that runs on my laptop, and that's great, and you can install everything on the laptop. I think there we're looking at gigs and gigs of pre-computed data. So it's a scale up. And the last thing is, so once you've massaged, so here, because R, and so this part, ggplot2, is a module of R. So it's the visualization module for R. You can have a very interactive discussion with your data. When we run it as a service, because we don't use R and I'm not going to give you my laptop so you can look at your data for every single customer. Obviously, we run that over the web, and we use another very similar technology called D3. So it's a JavaScript library to represent data in numerical data. So at the service level, I can show you really quickly what it looks like. So this is what it looks like. So here this is for the past 6 months. It has a number of different differences, obviously, with what I showed you before. The first one is here. This is something that, as a service, we say, okay, here's the data, which doesn't really, allows you with some interactivity, which I'm going to demonstrate in 2 seconds, but it's not quite as flexible as being in your R session and trying to crunch data and have fun with the stats. But the nice thing about, well, what we try to do there is basically to focus, and this is going back to the Tufte representation of visual information, of quantitative information, is to give you a few things. A, to give you week by week, so that is what I showed you before, except it's less granular, so it's bars as opposed to lines with a more granularity. And then try to give you kind of the top offenders for this particular week. So here, so it was last week, 51 alerts, there's a big jump, and these are like 2 actionable insights that we're trying to get to. So I think even as a guiding principle, whether you use with a service like ours, or whether you do it yourself, that's a key thing, is like, give me something actionable I can do. So that if I were to only do 2 things this week based on this report, I'd free up some disk space because it's been 3 weeks and it's probably not going to get better by itself. And then I would either fix this check or remove it if it's not very useful. So that's the general structure of the report. Now, an advantage that using D3 gives us over using R. So R is super interactive in terms of the questions you can ask, the answer you get. You ask a question, you get an answer. You ask a question, you get an answer. It's not very interactive in for you to click around because it basically spits out a graph. So you can then layer your wall with graphs and go crazy with that. But it's a slightly different mode of operation here. Being on the web, we try to do something that's a lot more interactive. So then we could, for instance, choose Friday, and this is UTC, so it's going to be 2 + 5, 19. Kind of what's happening at this hour. So it's really the same question, or the same question, the same answer that I was getting to before. Is given a day or given a day and an hour, what happened and what's the worst thing, or rather, let me see. Here, I think, if you look at day by day, this is the distribution day by day, so you can see it's kind of so for last week, it's heavily slanted towards the weekend. But again, applying the same mechanism, you can drill down and choose. Yeah, actually, I want this check, and I want to see when it alerts by hour and by day, and then how it's going. So you can see that it's kind of sloping down and then starts to go up. So there's something, we were good here, but things are getting worse. So so that's the kind of stuff you can build with D3. So it's a slightly different mode of operation. I think less analytical, more interactive, more exploratory, but less statistically minded, if you will. Okay. So we do a lot more, but I'm not going to bore you with that too much. So if you're curious about what I talked about, you can check us out, or you can Twitter me at I'm ALQ, or you can ask questions now, and I'll be happy to answer. And that's it for the presentation.
So your service and the process you're describing, whether done in just a play stack or in your service stack, it's pretty much in the space of, say, exporting all of your Nagios log data to Splunk. Although I haven't used it, I think NDO Utils is largely in the same space as well.
Is the question whether it's the same? Yeah, you could use Splunk. I mean, then it becomes a matter of I would say the depth of your analysis and your preference. So obviously, if you have Splunk already, there's a number of these things, the graphing by day and that kind of stuff, which you could do. It's a different representation. The strength of R in this case, I think, is a lot around if you want to forecast data, which I didn't get into, but you can analyze time series and apply a number of forecasting methods to see where you're going, extract trends, seasonals, and so on. So I would say Splunk is, so R, all that to say, R probably operationally, as in I want to deploy this in my enterprise and get a lot of people on it, probably not the way to go. But obviously you're here because you have a deep interest in monitoring. So I think that would still make sense for you to pull some data, play with it. I think the important thing is like to get some good insight out of it. It kind of doesn't matter, at the end of the day, it doesn't matter too much how, but long-winded way to say, yes, it's similar to what you can do in Splunk.
But presumably, and since you did this approach offers you things like forecasting.
Yeah, yeah.
That you're not going to get just from throwing that into Splunk or into
Yeah, and that's where you're in IT and you're kind of trying to go a little bit into to put a statistician's hat on your head. So I think it's a great way, for me, it's a great way also to learn more about statistics, like formally learn more about statistics and see what kind of questions can I ask, what kind of questions can the data answer, and I think equally importantly, what kind of questions the data cannot answer. And I think that so thinking back on the process, I think that's one of the hardest questions to answer is, so there's data, I can see a ton of, so obviously I have to make a hypothesis before I ask my questions. I can't, it's not like it's in the data and then it's going to manifest itself, without doing anything. But it's hard because the environment is inherently so much out of control. It's not a control experiment like you're doing, I don't know, physics or something. To really isolate, yes, this is a clear answer, or yeah, maybe, or no, I think it's this, but actually it's not. So I think that's inherently that's a difficulty behind the whole process, and I think a tool like R, because it lets you get more refined analysis, is a great way to start.
So I wasn't sure from the the two models and everything, if you were saying is R only interactive, or can you package up a program and run it on a schedule?
So you can do R. You can run on a schedule, batch it and get the results. It won't be interactive. Well, so it will be interactive, as in. Let me see if I have it here. Yeah. So as in something like this, where this is how I produce my graphs in there. They're a little bit. So I load the data. I run something here, and it just displays it. So this is interactive in that sense. It's not shareable, i.e. it runs on my box, basically. But you could have it spit out a PDF, for instance, on a weekly basis, and then email that to whomever is interested. So it's a slightly different mode. So the typical way you do it is you actually do it here, and then once you have it cut down, then you can see it's all it's sort of pseudo scripting language. So you just extract the program and then batch it, and then boom, you get your data. Anything else?
Any more questions? Well, then, if there's no more questions, thanks a lot, everybody, for attending the conference this year. From me, thank you very much.